Hey everyone, welcome to your Chapter 3 notes. Go ahead and start a new section of your notebook and title it Chapter 3, Parallel and Perpendicular Lines. You know in Chapter 1 how helpful your notes were for quizzes and tests and homework, so you're going to want to make sure that whether it's a video or in class, you're taking notes that you'll be able to look back on and use. So for 3.1, our learning target is I will be able to classify pairs of angles formed by two lines in a transversal. So make sure you have the chapter title and then the title of today's lesson 3.1 before moving on to the next slide. We're going to start chapter 3 with some vocabulary, just like we did in the previous chapter. Our first vocabulary word today is parallel lines. Now, this is a concept that you're probably already familiar with from previous classes, but our definition for parallel lines are any two coplanar lines that never intersect each other. So there's lots of examples of different coplanar lines in this box to our right. For example, I could say that BG and AH are parallel. They're both in the same plane, the left side of the box, and they're never going to cross or intersect. You might see a different pair of parallel lines. For example, I could say that DC going down on the right side of the box and FE are parallel lines. Or maybe EC along the bottom edge and DF along the top edge. Lots of different pairs of parallel lines. So go ahead and in your figure that you've drawn for the picture, just highlight at least one pair of parallel lines there. Then let's move on to our next definition, skew lines. Skew lines are any two non-coplanar lines that never intersect. So they never intersect, which is the same as parallel, but now they're not in the same plane across and are not in the same plane. An example of that could be A to C and F to E. They're in totally different planes of the box. A to C is in the front part of the box, while FE is in the back of the box, and they're never going to intersect. One is going side to side horizontally, one is going up and down vertically. Again, just like parallel lines, there are other examples here of skew lines. For example, I could say BD in the front of the box is a skew line with GH in the back of the box. They're going in different directions, but they're never going to intersect because they're in different planes of the box. Next, let's look at parallel planes. So different from parallel lines, where I'm just looking at two line segments in the box, parallel planes are two entire flat surfaces of the box. So they're two planes that are never going to intersect. So for this, I'm going to use my highlighter to show you two planes. I think the easiest two to see are the bottom of the box, which is the plane that covers points A, C, E, and H, as well as the top of the box. Those are two parallel planes. They're two flat surfaces that are never going to touch or intersect. So make sure you have those three definitions in your notes as well as this picture. And if you have them near you, different colors or highlighters to show the different pieces. So again, just so you remember, I used my highlighter for the parallel planes. Those are the two in yellow. I used my green pen for the skew lines, FE and A to C. And then I used my purple pen for the parallel lines. Our last definition is a transversal. The transversal is shown in the picture in red, so again, if you have different colors, that'll be helpful. And a transversal is a line that intersects two or more coplanar lines at different points. So notice that this red transversal intersects both of these black lines at different points, 1, 2. Pause here to make sure you have all four vocabulary words and their definitions as well as your pictures labeled before moving on to the next page. Here we have another page of vocabulary. You're going to want to set up this page so that you see the 5 different types of angles we're going to use throughout all of Chapter 3, as well as a picture of each. Notice that I use the exact same picture for each of the 5, but I would recommend that you also copy it into your notes 5 times just like I did, because I'm going to use these different circles to talk about different angles. So I think if you try and use the same picture for everything, you're going to end up drawing on it so much that it'll be confusing. Again, we want our notes to be helpful for quizzes and tests and homework. So I would recommend setting up your notebook like this with the 5 vocabulary terms, the 5 angles, a space for their definitions, and then a space for their picture. So when we have that transversal line that cuts through 2 different lines at 2 different points, a bunch of different angles are formed. The first type of angles are called corresponding angles. Corresponding angles are on the same side of the transversal in the same relative position. So let's take a look at what that looks like. In this picture, I could say that a pair of angles that are corresponding could be like, for example, angle 2. Angle 2 is on the right side of the line, and it's in the top right corner. Angle 2 is corresponding with angle 6 because they're both on the right side of the line and in the top right corner of their group of 4. Now, 2 and 6 is not the only pair of corresponding angles here. In fact, there's actually 4 different pairs. So you could say 2 and 6 is your example. Another good example would be, for example, 3 and 7. They're again both on the right side of the line, but now in the lower right corner within their group of 4. Another example of corresponding angles could be 4 and 8, both on the left side of the transversal line in the lower left-hand corner. And finally, the last pair of corresponding angles here could be 1 and 5, also both on the left side of the line in the upper left-hand corner. So in your picture, highlight one of those pairs. I'm going to leave mine highlighted on 1 and 5 to show the definition of corresponding angles. Then move on to alternate interior. Alternate interior is exactly like it sounds. It does 2 things. Alternate, meaning opposite side of the line, inside of the 2 crossing lines that cross over the transversal. So when I say inside, I mean it's in between these 2 lines that cross through the transversal. So there's actually 2 different pairs of alternate interior angles here. You could say that your example is 4 and 6. Notice they're on opposite or alternate sides of the transversal inside those 2 lines that cross through it. So they're in between those 2 lines. The other pair of alternate interior angles here would be 3 and 5. 3 and 5 are also on opposite sides of the transversal in between the 2 lines that cross through it. Highlight one pair of alternate interior angles and then go on to alternate exterior, which you can probably figure out is very similar. Alternate sides of the transversal or opposite sides of the transversal, but outside the 2 lines. So now I'm going to want to look on the outside of those 2 lines, and I could look at, for example, number 1 and number 7. They're on alternate opposite sides of the transversal, but now they are outside of those 2 lines that cross through it. Or similarly, the other pair of alternate interior angles would be angle 2 and angle 8. So make sure you have one pair of alternate interior angles shown and then move on to the next one. Finally, we have consecutive same side interior angles. These are 2 angles that are on the same side of the transversal, but inside. So now they're still inside those 2 lines that cross through the transversal, but they're on the same side of the line. So for example, I could say 4 and 6. Notice, 4 and 5. Notice 4 and 5 are on the same side of the transversal and in between the 2 lines. The other pair of consecutive same side interior angles would be 3 and 6, still on the same side of the line, in between the 2 lines, 3 and 6. And finally, consecutive same side exterior angles, still on the same side of the line, but outside of the 2 lines that cross through the transversal. So again, here we have 2 examples. You could either say, angle 1 and angle 8 for consecutive same side exterior, or on the other side of the line, you could say angle 2 and angle 7 are also consecutive same side angles. Before moving on to the next slide, make sure you have all the definitions down. We'll use these angle definitions throughout this entire chapter. So you're going to want to make sure you have the 5 vocabulary words, the 5 definitions, and then a picture of each with at least one example circled. I listed a bunch of different examples for each, but you're going to want to have at least one example circled before moving on to the next slide. When you're ready, go ahead and move on to the examples. All right, let's take a look at example 1. Name a line parallel to EC through point A. Let's take a look at where EC is. So we've got EC here on the bottom right corner of the box. I'm going to use my highlighter tool to show it. So we've got EC right here. We want to show a line that is parallel to that goes through point A. Well, a parallel line to that could be the line that goes from A to H. So A to H would be a parallel line with EC. Let's take a look at another example, B. Name a line parallel to EC through point D. Well, now we've got EC, which is still our parallel line, but now we want the parallel line to go through D. Let's take a look. Here's EC, again, still highlighted in purple. Point D is up at the top of the box. A parallel line would also be D to F. Notice D to F and E to C still in the same plane, the right side of the box, but again are never going to cross or intersect one another. Next, let's take a look at example C. Name a line skew to EC through point A. So we already have EC highlighted in purple. Now we're looking for a skew line that goes through point A. Remember, a skew line needs to be one that is not in the same plane as EC and does not intersect it. So I'm going to highlight in green. So we have EC still over here on the right bottom side of the box. We want a line through point A that is skew. An example of a skew line through point A would be BA. It is not in the same plane as EC. EC is on the right bottom side of the box. A to B or B to A is on the left front side of the box, and it goes in the opposite direction. B to A is a vertical line while E to C is a horizontal line. So we can either call that line B to A or A to B. Next, we want to find a skew line to DC through point H. So let's highlight this one in a different color. So we've got DC here in the front side of the box. And we want to find a line that is skew with that. There are lots of different options for a line that is skew with D to C through point H. Specifically is going to just be one line from the back of the box, H to C. Again, notice that H to E is going in a different direction than DC. H to E is a horizontal line, while D to C is a vertical line, and it's in a different plane. DC is in the front of the box, while HE is in the back of the box. Another example could have been E to H, or A to H would have also been a skew line. So notice E to H is one skew line because it's in the back of the box. However, a second example of a skew line, we also could have said the line that goes from A to H. Notice A to H and DC. A to H is still a horizontal line, while D to C is a vertical line, and they're in different planes. A to H is in the bottom of the box, while D to C is in the front right side of the box. Finally, we're going to look at some parallel planes. First, I want to look at a plane that is parallel to BDG. BDG are 3 letters that are on the top part of the box. So BDG is in this top plane at the top of the box. A plane parallel to that would be the bottom of the box. Remember, to name a plane, we just need to use any 3 letters. So as long as I use any 3 letters in the bottom of the box, my answer will be correct. So as long as I use some combination of A, C, E, and H, I only need 3 of them. So I chose to write plane ACE or ACE. But again, any answer you have that uses 3 letters with any combination from A, C, E, and H in any order would be correct. Finally, a plane parallel to ABD. ABD is the front of the box that also includes point C. So a correct answer will include any combination of the letters at the back of the box. So any combination of the letters from E, F, G, and H. I chose to call it plane EFG, but again, you can also use H as your third point in any combination. So I could say FEH, GEH, any combination of the 4 letters at the back of the box. This is our last example for today. We want to name different angles in the 2 lines with the transversal. First, we want to name all 4 pairs of corresponding angles. So remember, corresponding angles are on the same side of the line and they're in the same relative position. So we could say that one example might be A and E. A and E are on the same side of the line in the same position. So they're both on the left side of the line, both in the upper left-hand corner within their group of 4. There are 3 other pairs of corresponding angles, B and F, C and G, both in the bottom left corner, or finally D and H. Those are your 4 pairs of corresponding angles, same side of the line, same position. Next, let's look at the pairs of alternate interior angles. Alternate interior angles are on opposite sides of the line in between the 2 given lines. So an example of alternate interior could be C and F, or another example of alternate interior could be D and E, also on opposite sides of the lines in between the 2 given lines. Similarly, alternate exterior angles are on opposite sides of the transversal but outside of the given lines. So we have 2 pairs, either A and H, which are on opposite sides of the transversal outside of the 2 given lines, or B and G. Next, we have same side interior angles. Those are on the same side of the line in between the 2 given lines. One pair of same side interior angles could be D and F. They're on the same side of the line, D and F, and they are both inside of the 2 given lines. The other pair would be C and E, both inside and on the same side of the line. C and F are on the left, C and E are on the left side of the transversal, D and F are on the right side. Finally, a pair of same side exterior angles that are on the same side of the transversal outside of the 2 given lines could be either A and G, or the second pair would be B and then H. So we've got B on the top right corner and then H in the lower right corner. Those could be another pair of same side exterior angles. So again, either B and H in this situation or A and G would be our pairs of same side exterior angles that are on the same side of the transversal outside of the 2 given lines. So we've got A and G or B and H. This ends your notes for 3.1. I'll be able to classify pairs of angles formed by 2 lines and a transversal. Remember, we learned 4 different vocabulary words: parallel lines, skew lines, parallel planes, and transversal, and then 5 different types of angles that are formed by those parallel lines and a transversal. Those 5 angle types are corresponding, alternate interior, alternate exterior, same side interior, and same side exterior.